Hi dear students, this is a continuation video for carbon and its compounds, third part, in which we have discussed about versatility of the carbon. So we know, compared with the other elements of the periodic table, carbon forms a large number of compounds because it has a special ability that is known as catenation, ability of self-linking, and the carbon valence is 4, so it can form covalent bonds with the other elements like hydrogen, sulfur, nitrogen, phosphorus. So that is the reason why it has the many compounds. It is around 10 millions. In this video we are going to discuss about saturated and unsaturated hydrocarbons, right? Saturated and unsaturated hydrocarbons. Saturated hydrocarbons. Saturated hydrocarbons. Students, hydrocarbons are the compounds. Hydrocarbons are the compounds which contain only hydrogen and carbon atoms, right? So these hydrocarbons mainly classified into 3 types. Hydrocarbons are mainly classified into 3 types. 3 types, right? One is alkanes. Second one is alkenes. Third one is alkynes. Alkynes. General formula is CnH2n plus 2, right? For the alkanes, CnH2n. Here CnH2n minus 2 for the alkanes. For example, if we take one alkane, that is first alkane is methane, CH4, methane, right? So here n place, if you substitute 1 in the formula, this is a general formula. So n place, if you substitute 1, you are getting C1H2 into 1 plus 2, which is a CH4. So the first member of alkane groups, that is alkane group, is methane, CH4. So alkenes case, you take if you substitute n is equal to 1, we are getting CH2. So this is unstable because carbon generally it forms 4 covalent bonds. If it is only 2 hydrogens are there, 2 bonds is possible, this is unstable. So first alkene, it will start with the n is equal to 2. When we substitute n is equal to 2, we are getting the formula C2H4, which is known as ethene, right? The first member of alkene series is ethene, right? Alkynes case, n starts from 2, n is equal to C2H2 into 2 minus 2, this is C2H2, which is ethane, right? Students, when the carbon forms a single bond, that is generally called as a saturated hydrocarbons. Later in the higher classes, we are going to study ring compounds, also called as ring compounds are called as unsaturated, even they have single bonds, right? So for our syllabus, This alkenes and alkynes, we can call it as a unsaturated. Unsaturated. Alkanes, we can call it as a saturated. Let us take some examples about saturated and unsaturated. Dear students, for the saturated hydrocarbons, we will take CH4. CH4. Carbon valency is 4, right? So we know that carbon atomic number 6, electronic configuration 2, 4, right? So first shell contains 2 electrons, outermost shell, second shell contains 4 electrons. According to octet rule, it will try to achieve 4 electrons. So earlier class we have discussed carbon cannot lose 4 electrons, it cannot gain 4 electrons. Generally, it will share some 4 electrons with the other atoms. So carbon can form, carbon valency is 4 and carbon can form only covalent bonds. Covalent bonds, right? So it cannot form ionic bond because it is very difficult to remove 4 electrons, or it is difficult to hold 4 electrons if it gains with the 6 protons inside the nucleus. So carbon generally forms a covalent bond. Covalent bond which forms due to mutual sharing of electron pair. So when we take a CH4, carbon is the central atom, right? So carbon, it is making a bond with the single bonds with the 4 hydrogen atoms. Okay, all the bonds are single bonds. Then we can call it as a saturated, right? So this is around the carbon we can check. When there is a single bond, one dash indicates one covalent bond. There is one pair of electron is shared between 2 atoms. Here one pair. Around the carbon it has 8 electrons, octet is completed. Hydrogen generally it will try to achieve duplate, 2 electrons, that is also completed, right? So this is called as a saturated hydrocarbon which has a single bonds, all the bonds are single bonds. Let us take one more example. A CH4, generally I will show you the model of CH4. The carbon which is called as a tetrahedral shape like this, right? Carbon, let us assume this black color ball as a carbon, and each hydrogen is bonded with the carbon with a single bond, right? This line indicates one bond. This shape, that is a 3-dimensional structure of CH4 methane, which is tetrahedral. The shape of this molecule is called as a tetrahedral, right? This is the first member of alkanes, right? CnH2n plus 2 is a general formula. Second member, ethane, will be like this. When 2 carbon atoms are there in the alkane, in the CnH2n plus 2, we will get ethane, right? I will write here. Second member of alkanes, general formula is CnH2n plus 2. When we put N is equal to 2, we are getting the name of that hydrocarbon is ethane. Later we will learn about how to give the names. Ethane, right? So when we put N is equal to 2 in this formula, C2H2 into 2 plus 2, which is C2H6 we are getting. So one carbon is bonded with other carbon by single bond, and each carbon is bonded with the 3 other hydrogen atoms. Anyway, carbon will make covalent bonds and it will make maximum of 4 bonds because its valency is 4. This is ethane. Okay, each carbon, this is carbon. Between carbon and carbon there is a single bond. Here with the hydrogens, this particular carbon, it has 3 hydrogens, CH3CH3. Okay, combiningly we can call it as C2H6 ethane. This is also a saturated hydrocarbon. All the bonds are single bonds are present. Now let us continue our discussion with the unsaturated hydrocarbons by taking 1 or 2 examples. Dear students, next is unsaturated hydrocarbons. Unsaturated hydrocarbons means the hydrocarbons which contains at least 1 double bond or 1 triple bond. Hydrocarbons containing at least 1 double bond or triple bond is known as unsaturated hydrocarbons. Okay, hydrocarbons, right? Unsaturated hydrocarbons, right? Then under this category, according to our syllabus, alkenes will come. Alkenes, other alkynes also will come. Right? Here general formula is CnH2n. Here general formula is CnH2n minus 2. The first member we will get of alkenes by substituting n is equal to 2. Then we will get the formula as C2 2 into 2 because n is equal to 2. 2 2s are 4. C2H4 we are getting. So in this case it has a 1 double bond between 2 carbons and 4 hydrogens equally shared between 2 carbons, right? So for each carbon 1 2 3 4 bonds. For this carbon 1 2 3 4 bonds. Valence is satisfied. The structure will be like this. Here this black color bars are carbon. In between these 2 carbons there is a double bond. 1 2 double bond it is here. This is with the each hydrogen it is bonded with the single bond, right? CH2, right? Which is C2H4, which we can call it as unsaturated. If there is a 1 double bond or more than 1 also, that is called as unsaturated. Or if it has 1 triple bond or more than 1 triple bond also called as unsaturated. For the alkane, first member we will get by substituting n is equal to 2, so that we will get it as C2H2, which is known as ethane, right? General name of ethane is esterene. Esterene is a general name. Ethane is a UPSC name, right? These compounds together, alkenes and alkynes, are called as unsaturated hydrocarbons, right? So when we take this compounds, there is a one word will come, that is important thing, homologous series. If we take alkenes, alkynes, right? So first member of alkane is CH4. Second member is C2H6. Next C3H8. Right? Here you will get for alkynes C2H2. Then C3H4. Right? C4H6. Here C2H4. C3H6, C4H8, like this it will come. This is a first member of alkene, first member of alkynes, first member of alkanes, right? CH4, C2H6, C3H8, like that it will come, right? Later members. When we take the difference between two successive members, right? This is CH4, C2H4. The difference we get it as a CH2. Difference here we get it as a CH2, right? This is CH2. Difference is CH2. Here also CH2. Here also we get it as a CH2. So this complete set of compounds is called as a one homologous series. They have general formula, same general formula, same method of preparation, similar chemical properties for different physical properties. With the successive member, the difference is the CH2, that is called as a homologous series. Right? Let us learn about the homologous series. Students, next is we are discussing in detail about homologous series. Homologous series. The group of organic compounds. Organic compounds is nothing but carbon containing compounds with same general formula, with the difference of CH2 between two successive members, same chemical formulas, chemical properties, same chemical properties, but different physical properties, with almost similar method of preparations, similar methods of preparation is known as homologous series. Friends, the successive member, when we are taking alkane, first alkane is CH4, second one is C2H6, third one is C3H8. The successive members should differ by CH2 and same general formula, different physical properties like boiling point, melting points. Those properties may be different. It is completely different, but chemical properties are similar. Same methods of preparation. That set of compounds is called as a homologous series. Students, in the unsaturated compounds, we can also take the benzene as an example. Benzene is unsaturated hydrocarbon. Its formula is molecular formula C6H6. In this, 6 carbon atoms are there, and it has alternative double bonds, and each carbon is bonded with the one hydrogen with a single bond, right? C6H6. The formula, that model for the benzene will be like this. Students, here you can see 6 carbon atoms are there, 1, 2, 3, 4, 5, 6, and alternative double bond. Here single bond, double bond, single bond, double bond, single bond, double bond. Alternative double bonds are there, and Each carbon is bonded with the hydrogen by a single bond C6H6, right? This is about the saturated and unsaturated compounds. Benzene is unsaturated only, and homologous series. Next class we will continue with the next topic. Thanks for watching.